Hello, welcome everyone. Welcome back to my channel. Today we are doing worksheet on Frustums of Pyramids. Well, before we'll start the classes, I'm running GCSE crash course and it's just at £6 per hour. The group classes are pretty small. They are highly interactive. Obviously, the videos, the recorded sessions and the interactive sessions are way different from each other. In classes you'll be able to get more clarity on the topics, and especially in the group classes every student has their own, like when different minds meet you'll be able to know more things. Okay, so that's a great advantage of it. Also, if you're looking for any subjects from year 1 to year 13, just email us at exactacademy@gmail.com to book your free demo. If you're looking for worksheets, just visit our website, which is exactacademy.com. So let me start with the question number 1, which you can see here. It says, find the total surface area of the figure 1. Figure 1 is clearly the frustum. And frustum of what? Pyramid. And we know if we want to calculate the total surface area, a total surface area is the area of all the surfaces. We can clearly see there are 6 surfaces, the bottom one, the upper one. The bottom one, it's clearly as a square base pyramid. So bottom and the top surfaces are the square, whereas the other 4 sides are pyramids. So we just need to find the area of each and just add it up. I'm starting with finding the area of the base, which is 20 times 20, which is 400. Then I'm finding for the top one, 10 times 10 is 100. Then for pyramids, clearly in pyramids, these 2 sides are equal. This is also 10, this is also 20, because it's a square base pyramid. So the parallel side of each pyramids are equal, as well as the distance between them is also equal. That means every 4 pyramids are exactly equal in area. So I just need to calculate the area of 1 and then multiply by 4 to get all the surfaces. So half times at the 2 parallel surfaces times the height between it. And I'm directly multiplying 4 here. That will give me the total surface area of all the 4 pyramids. This will be 30 times 80. That will give you 2400. That means total surface area is 2400 plus 400 plus 100, which will give you 2900 centimeter squared. And this is your final answer. Moving on to the next question. A frustum is made up of a square base pyramid. That means again I'll get to know that this is a square base pyramid. So the base, and even if I'm talking about this one, is a square. The length of the base of the pyramid is 20 centimeters. The height of the original pyramid is 40 centimeters and the cutoff small pyramid is 10. That means the height of that cutoff small is 10, and we have to find the volume of the frustum. See, if we want to calculate the volume of frustum, we should know that a frustum is made up of a pyramid. This is your original pyramid. When you cut off a small pyramid out of it, the remaining portion is called the frustum. So to calculate the volume of the frustum, I just need to calculate the value of volume of the pyramid and subtract the volume of the small pyramid. So I'm starting with finding the volume of the bigger pyramid. Formula is always 1/3 times area of the base times height. So volume of frustum is volume of pyramid, that means volume of bigger pyramid, minus volume of smaller pyramid. Always remember, but that doesn't apply in total surface area. Don't do this, that total surface area of frustum equals total surface area of bigger pyramid minus a smaller pyramid. You will end up getting the wrong answer. So volume of smaller pyramid. For curve 1 we can do that, but not for the total surface area. Now I have to calculate volume of bigger pyramid. as I told you, formula is 1/3 times area of base times height. So area of base, we know it's a square based pyramid, so it's going to be 20 times 20, and height is given as 40. So the base is 20, so it's going to be 1/3 times 20 times 20, and the height between which is 40, so that is 40. So it will give you 40 times 20 times 20, so it's going to be 16,000/3. This is the volume of pyramid. Now volume of smaller pyramid now. So volume of smaller pyramid will be, you can clearly see the height is given as 10 and the base is not given. In theory, I have explained that they share, the smaller pyramid and the bigger pyramid are actually the similar figures, and if they are similar figures, that means their corresponding sides are in ratio, they are proportional. So I know that the height of the bigger pyramid is 40 and height of the smaller pyramid is 10. That means 4 is the scale factor. And if 4 is a scale factor, which means if this is 20, so I get to know that the smaller one is 1/4 of it. That's the meaning of scale factor. So if I'll divide 20 by the, let's say this be x, so it will be equals to 4 as well, because every side has the same scale factor. So it's going to be x is 5 centimeters. So I get to know that the base is 5 centimeters. So I can easily calculate the volume of smaller pyramid. So volume of smaller pyramid is 1/3 area of base. Base is 5. So 5 times 5, because a square, the area of a square is 5 squared. That is 25 times the height, which is 10, which will give you 250/3. And finally, the volume of frustum, I'm just running out of the space, so I'm just writing here. So volume of frustum finally is volume of the bigger pyramid, which is 16,000/3, minus volume of smaller pyramid, which is 250/3. And this is how we can calculate the volume of the frustum. That is equals to 15,750/3, which is equals to 5250 centimeter cubed. Part B says find the total surface area of the frustum. So for the first term, I already know that this is 40 times 40. This is 10. Sorry. This was 20. So this is 20 times 20. This is 10 times 10. Only we don't know this length, this one, because we should know the distance between two parallel sides. So that can easily be calculated if I calculate this one. From the pyramid, it's very easy for me to calculate. What I need to do is I just need to join it like this. And this will give me a triangle, a right triangle. Now it's easy to calculate. I'll show you why I'm doing it. First of all, let me calculate this. This is actually the height of each triangles. Okay, not the height of the main pyramid. That's a 3D height. I mean, obviously, it's going in a space vertically. Whereas this height that I'm calculating is basically this one. This is the height of the triangle. If you want to calculate the area of the triangle, this height will be helpful. So triangles of the sides. So if I join this one, and this one from the center, this will give me the triangle and it will help me in finding it. Clearly this is 90 degrees. So the height that I'm finding is hypotenuse. This is 20. So this is half of it, that is 10. This is 10 clearly. This height is given as 40. So I have to apply Pythagoras theorem. So to calculate height, of triangles of bigger pyramid, we can use Pythagoras theorem. So it would be clearly 10 squared plus 40 squared. So 10 squared plus 40 squared is equals to hypotenuse squared, which is 1600 plus 100, and this is equals to 1700, and on taking root I'll get answer as it's 41.23 centimeters. Now we know that they share a scale factor. If this bigger one is 41.23, so this is smaller one, if I want to calculate the height of these triangles of the smaller pyramid, it has to be divided by 4 because that's a scale factor, and this will be 10.30. So I can write out 10.31 if I round it off. So then I can say that height of triangles of smaller pyramid will be 41.23 over 4, which is equals to 10.31. So this means the height of the trapezium of frustum. So height of trapezium of frustum is clearly, you need to subtract it. So height of trapezium of frustum is 41.23 minus 10.31. So this will give me 30.92. So I just need to subtract. Now I can easily calculate the total surface area of the frustum, because now the total surface area of frustum is area of the base, which is 20 times 20, plus area of the top part, which is 5 times 5, plus prism. If you want to calculate the area of the trapezium, this will be half times. And also, I just did mistake here. This is not 10. This is 5 that we have calculated, right? Yeah. So half times 20 plus 5 multiplied with the height between them, which is 30.92, times 4, because there are 4 such trapeziums. And this final will be, it's 1971 centimeters squared. This is basically the total surface area of this frustum. Moving on to the next question. Question 3 says, in the figure given above, each side of the upper and the lower regular hexagon is given as 6 centimeters and 24 centimeters respectively. The distance between two parallel sides of hexagon is 50 centimeter. Find the total surface area of this figure. It's easy. We just have to calculate the area of the top part, bottom part, and the area of trapeziums. First, let me start with finding area of trapezium, which is half times sum of the parallel sides, which is 6 plus 24, times the height between two parallel sides, which is 50. And this is not a square based, it's instead a hexagonal. That means there are 6 such trapeziums, so I need to multiply by 6. This will give me total surface area of the curved part, that is of all the trapeziums. And now I have to calculate for the top part and the bottom part. For the top part, let me show you one thing, and the bottom part basically, they are actually a regular hexagon. For a regular hexagon, if we do like this, it will be divided into 6 equilateral triangles. So these are basically 6 equilateral triangles. That means if it says this side is 24, so every side would be 24, and so does these sides. So simple. they all are the equilateral triangles with side 24 centimeters. So this is area of O trapeziums. Now area of bottom hexagon. That means for the bottom hexagon, as I told you, the regular hexagon is divided into 6 equilateral triangles, and the area of equilateral triangle is √3/4 a squared. A squared represents the side of the triangle, which is 24 in this case. This is the area of one equilateral triangle, and a hexagon is made up of 6 equilateral triangles, so I'll be multiplying it with 6. And similarly, area of top part or the smaller hexagon, the top hexagon, and this would be √3/4 times 6 squared times 6. And after calculating all, I need to add them up. It will give me the area, the total surface area of this given frustum of pyramid. So final answer is, finally total surface area is 6090.02 centimeter squared. Now moving on to the question number 4. Now it says in the figure given above, the volume of frustum is 744 centimeter cubed, and the volume of the original, that is a large pyramid, is 750 centimeter cubed, and we have to find the ratio of H1 and H2. So in the figure above, the volume of original, the larger one, is 750, and volume of the smaller pyramid, volume of the frustum is 744. So volume of smaller pyramid will be what? Clearly, if I subtract volume of bigger cone, volume of bigger pyramid minus volume of frustum. So volume of bigger pyramid is given as 750 minus volume of frustum, which is 744. Answer is 6 centimeter cubed is the volume of that smaller, this one is 6 centimeter cubed. Why I have calculated the volume of smaller one? Because they are asking you to calculate H1 and H2, and H1 is height of the bigger pyramid and H2 is the height of smaller pyramid. That's why, because we know that volume scale factor is always the cube of length scale factor. So H1 and H2, if I divide them, will give me length scale factor clearly. And when I divide the volume of bigger and the smaller cone, I'll get the volume scale factor. So volume scale factor is volume of bigger cone, which is 750, and volume of smaller cone, which is 6. This will give me the volume scale factor. So 750 over 6 is 125, and this is your volume scale factor, and volume scale factor is equals to L cubed. That means length scale factor. So volume scale factor is equals to cube of length scale factor. So 125 is equals to L cubed. From here, taking cube root to both the sides, it will give me 5. That means if I'll divide the H1 and H2, it will give me 5. That's what the length factor is. So H1 over H2 is 5, and that's the answer. Moving on to the next question. In the figure given in the question 4, it's basically a continuation of question 4, but a whole different question rather than the part of it. In the figure given in the question 4, is the height of the smaller pyramid is √3 centimeters, and the length of each side of the hexagon of bigger pyramid is 10 centimeters. We have to find the total surface area of the frustum. See, so now we do have the length scale factor, which is 5, and what else is given? The height of the smaller pyramid is √3. If height of a smaller pyramid, is √3, so clearly we know the length scale factor is 5. So height of bigger pyramid is 5 root 3. So now it says the length of each side of hexagon is of bigger pyramid is 10. So which means this side of the hexagon is 10 basically. And if this is 10, we know the scale factor is 5. So for the smaller one, it's going to be 10 over 5, which is 2. So I can say that sides of bigger hexagon is 10. I can calculate the area of hexagon, which I told you that a regular hexagon is basically made up of 6 equilateral triangles. So it would be root 3 over 4a squared times 6. Similarly, area of smaller hexagon, and we know the side of each smaller hexagon would be divided by the scale factor, that is 10 over 5, which will give you 2. So root over 3 over 4, 2 squared times 6. This is how we have calculated the area of the top and the bottom part. Now we have to calculate the area of trapezium. So pay attention properly, because you have to apply Pythagoras theorem 2 times here. First one is we will be applying the Pythagoras theorem in between this one. This because we have to find a right angle triangle. Join this one and this one. This is an easier way to clear you with the diagrams basically. So there is other way as well, but I feel like showing and explaining you on this diagram is much more easier this way. So this is a triangle. Clearly this is the height, which is already we have calculated as 5 root 3, and this bottom one is actually because they all can be divided into equilateral triangles. So whatever be this length is exactly the same, and the length of each hexagon is given as 10. So this is also 10. So we have to apply Pythagoras theorem in order to calculate this, and this is hypotenuse. So let's say this is hypotenuse. So hypotenuse squared is equals to 10 squared plus 5 root 3 whole squared. This would be 100 plus this is 25 times 375. So h squared is equals to 175. I'm not taking root because again we have to apply the Pythagoras. That's why. Once we are done with calculating of this one, now again we have to apply Pythagoras here. This we have calculated now, this hypotenuse. Now again, if I want to calculate only, this is now the 2D triangle that I can see here, not the height, that height of the pyramid, not the height of the triangle I'm calculating. Again applying Pythagoras theorem. So this is still your hypotenuse. This base is half of the length, which is 5, and this we have to calculate. So let's say I name it x. So h squared is equals to x squared plus 5 squared. H squared is 175, x squared plus 25. So this will give you 150 equals x squared, and on taking root, this will be 150 root of it. And in decimal, it will give me 12.24. So 12.24, we have calculated the height of the triangle. Now it's easy. Why? I can calculate area of this triangle. Half times base, which is 10, times height, which is 12.24. That will give me, so this is equals to 61.23. This is the area of each triangle. Now if we can calculate the area of a smaller triangle, so area of bigger triangle, and then if I'll subtract the area of smaller triangle, it will give me the area of the trapezium clearly. So I'm just opting the other way. Rather than finding the distance between the two parallel sides of the trapezium, we can calculate the height of the area of the bigger triangle and subtract the area of smaller triangle. So for smaller, I have to use the length scale factor. That means this length is clearly given as 2. So this half times I'm applying area of smaller triangle. Half times base. Base we knew that 10 for the bigger one and 5 was the scale factor. So clearly for smaller one, it would be 10 over 5, that is 2. Half time base, and height would be, we have calculated our height as 12.24. So again the scale factor is 5, so 12.24 divided by 5 will give 2.448. So area of the smaller triangle is 2.448. And now we can calculate the area of the trapezium, which is 61.23 minus 2.488. So here I can write area of trapezium is 61.23 minus 2.448, which will give you 58.782. And there are 6 such trapeziums, so multiplied with 6. So area of O trapezium 352.692. This is the area of O trapezium. Now to calculate the total surface area, I just need to add the area of OLID. That means the bigger hexagon, the smaller hexagon, and the trapeziums, and need to add them up. This is equals to 106.06, and this one is equals to, and this one is equals to 4.24. I need to add this one, and this all up. It will give me the total surface area, which is 462.995 centimeters squared. This is the total surface area. Moving on to the next question. Question says a hemispherical bowl of radius 5 centimeters is filled with water. This water is then transferred to a pyramid. Okay. If the base of the shape is 10 centimeters by 10 centimeters, because it's a square base pyramid, the height of the pyramid is 30 centimeter. Here it's a frustum one given. Actually it has to be a pyramid in the diagram. The height of the pyramid is 30, then we have to calculate the height of the water level in this pyramid basically. So from here I can clearly understand that whatever be the water in the hemispherical bowl, the same volume will be remain inside the pyramid when you pour it, obviously, because the same water you are transferring, so the volume will remain same. Also it says the water has completely filled the hemispherical bowl. So if I'll calculate the volume of the hemispherical bowl, I can calculate the volume of the water. So we know hemispherical bowl, volume of hemisphere is 2 over 3 pi r cubed. So this will be 2 over 3 pi r, and r is the radius, which is pi cubed. This will give me the volume of water. This is 261.6 centimeter cubed. Now the next is we have calculated the volume of water. That same water is then transferred to the frustum, and water takes the shape of the frustum, obviously shape of its container. That means now the same volume is poured in a frustum, so that will become the volume of the frustum. We know volume of frustum is volume of bigger cone minus volume of smaller cone. So volume of frustum is 261. Now the volume of bigger cone, we clearly know the base is 10 and the height of the pyramid is 30 given. So we know the volume of pyramid is 1 over 3 times area of the base, which is 10 times 10, times height, which is given as 30, minus. But for the smaller volume, obviously, suppose this is a pyramid and water has been filled till here. So the water will take the shape of a frustum clearly. So that means this pyramid I'm talking about, this pyramid, if I'll calculate the volume of this whole pyramid and subtract this unshaded one that I have drawn, then you'll be able to find the volume of the frustum clearly. So this base, we don't know that one, right? And that's why, but there has to be some scale factor clearly. So in that case, I can write 1/3 volume area of the base, but I don't know. But clearly they will share a length scale factor, obviously, because they are similar figures. So I can write the height is 10, so it has to be some value 10 multiplied by the length scale factor. So I will say 10 times L. I can write, so 10 times L, 10 times L. And same I can write for 30 times L. Or simple, this is the one way. Or the second way, I told you that volume scale factor is what? When you divide the volume of two similar figures. So I know the volume of one figure, the bigger one, which is 1/3 times 10 times 10 times 30, which is 1000. So obviously the volume of the smaller cone will be 1000 times L cubed. That is your volume scale factor. So this would be 261.6 is equals to 1000 minus 1000 times L cubed. This will help us in calculating the value of length scale factor. So then I'm just writing it here, the rest of the part. So 261.6 is equals to, taking 1000 out as common, 1 minus L cubed. This will be dividing both the sides by 1000. It will give me 0.261 equals 1 minus L cubed, or L cubed is equals to 1 minus 0.261. And on cube rooting, it will give me 0.903. So length scale factor is 0.903. So that means it will help us in calculating the value of height up to which the water will be filled. So height of the tutor, everything will be shared, right? So if I have this length scale factor, that means every smaller pyramid's length is 0.9 times of the bigger ones. So this we have calculated. Now, because we want to know the height of the frustum of the water, because water has taken the shape of the frustum, so what will be the height up to which the water will be filled? We already know the actual height of the pyramid, which is 30 in this case. So the height of the smaller pyramid will be 30 times 0.903. This is height of smaller cone. This is equals to 27.086. And height of the frustum would be 30 minus 27.086, which is 2.91 centimeters. So this is actually height of the water filled. This is how we can solve this one. The last question says, a square base pyramid has a volume of L centimeter cubed. A small pyramid of the volume L1 is cut off from its top. If the ratio of the slant height of the bigger cone and the frustum is 5:3, then first thing is, this slant height, that means this is your slant height. The slant height of the bigger cone, that means this bigger cone, and slant height of the frustum is 5:3. Okay, not the scale factor is 5/3. Don't get confused, because the scale factor is when you divide the corresponding sides of the bigger pyramid and the smaller pyramid. We don't know. Let's say that slant height of bigger cone. So let I convert the ratio into numbers. So slant height of the bigger cone is 5x. That means slant height of frustum is 3x, clearly that's the ratio given. So slant height of smaller cone obviously will be 5x minus 3x, which is 2x. So your length scale factor in this case is clearly the slant height of the bigger cone over slant height of the smaller cone, which is 2.5, and that's your scale factor. So they are asking, then a small pyramid volume is L1 is cut off from it and the bigger is L. So L over L1 is nothing but volume scale factor. And we know volume scale factor is cube of length scale factor. So this will be 15.625, and this is the ratio of L and L1. Then volume of the frustum in terms of L1. So volume of frustum is volume of bigger cone minus volume of smaller cone. Volume of bigger cone is clearly L, and volume of smaller cone is clearly L1. So L minus L1. Also we do have L over L1 is 15.625. So I have to use this ratio 625. I can write L as 15.625 L1. And now substitute the value of L, because your answer should be in terms of L1 only. So 15.625 L1 minus L1, that is 14.625 L1, and this is the volume of the frustum in terms of L1. So that's it for today. That was all about the frustum of pyramids. If you need one-on-one live online classes or group classes for any subject, I'll again say that the recorded sessions are completely different. The environment is completely different in online classes. You can ask questions. The experience is completely different. So to book a free trial, just drop us an email at AQA Academy@gmail.com. So that's it for today. Bye everyone. Take care.